Okay, so for sine, we see midline shift of 3, phase shift, there's nothing getting added or subtracted, so 0 or none. Amplitude, the coefficient's invisible 1. Period, we know the parent sine function has period of 2 pi. In this case, b is 2, so 2 pi over 2 is 1 pi. Okay. So I'll do domain and range later. Alright, so I know the basic sine function looks like this. Okay, I know that on the unit circle, sine is the y values. So starting at 0, y value 0, it increases up to 1. Then halfway around the circle, it gets back to 0. Then the y value decreases to -1. Then it returns to 0. Okay, so I know that there are midline points at the beginning, middle, and end of the period. Right? Beginning, middle, and back around to the end. Okay, so in this case, there's no phase shift, so that's nice. But I do have a midline shift of 3. Okay, so I'll just do that first. Alright, so next, I should identify my period. I'll begin at 0 because there's no phase shift. Okay, and then my period ends after pi units. So 0 plus pi is pi. Okay, so at the beginning of the period, it has a midline point, and in this case, the midline is +3. Then also at the end of the period, it has another midline point. And then halfway through the period, so halfway between 0 and pi is pi over 2. There's another midline point. Okay, so halfway between these two midline points, I know there's a maximum. And the maximum, in this case, the amplitude is 1, is just 1 unit above the midline. So starting at 3, 1 unit up means 4. Okay, and the maximum occurs halfway between 0 and pi over 2, which would be pi over 4. Okay, the minimum occurs halfway between these points, so halfway between pi over 2 and pi is 3 pi over 4. And the minimum is the amplitude below the midline, so 1 unit below 3 is 2. Okay, so I know that sine has no values which don't work, and then the range I can see goes as low as +2 and as high as +4. Okay, cosine, so I see midline shift of -1, phase shift x minus h, in this case h is positive pi over 4. Amplitude is 3, period is normally 2 pi over b, and b is invisible 1, so period is simply 2 pi. Okay, so what does the basic cosine function look like? So again, looking at the unit circle, cosine is the x values. So at 0 degrees, the x value is 1. Then the x value decreases to 0, keeps decreasing to -1, starts increasing back to 0, and increases back to 1. Okay, so it begins and ends at x equals 1, meaning cosine begins and ends at its maximum. Okay, so that was sine. So cosine then looks more like this. Okay, so I'll start with my midline of -1. Okay, so normally I would start my cosine graph at 0, x equals 0 I mean, but because of the phase shift, I move pi over 4 units in the positive direction, which is to the right. Okay, so I'll label pi over 4. Okay, so where should my period end? Well, the period is 2 pi, so when I start at pi over 4 plus 2 pi takes me to 9 pi over 4. Okay, so I'm just going to label my other x values right now. I know that halfway between these points is important. So pi over 4 plus 9 pi over 4 is 10 pi over 4, divided by 2 would be 5 pi over 4. Okay, and halfway between 1 pi over 4 and 5 pi over 4 is 3 pi over 4. And halfway between 5 pi over 4 and 9 pi over 4 is 7 pi over 4. Alright, so cosine, again, starts at its maximum. So in this case, the midline is -1, and the amplitude tells you go 3 units above that. So 3 units above -1, 0, 1, 2, is +2. Then it ends at a maximum as well. Halfway between the maximums is the minimum. So the minimum is 3 units below the midline. So 3 units below -1 is -4. And then in between the minimums and maximums, we have midline points. Okay, so domain, I know cosine can be all real numbers. The range goes as low as -4 and as high as +2. All right, tangent. So first I noticed that I have to factor out the b value. Okay, so amplitude 0.5, phase shift, remember it's x minus h, so to turn to a plus sign it must have been minus a negative. Okay, midline shift, there's no, well, the k value is 0, so none. Period, so normally tangent's period is pi, so in this case b is a half, so pi over 1/2 becomes 2 pi. Okay, so what does the basic tangent function look like? Okay, so tangent, sine divided by cosine. Okay, so I mean, if I start at 0 on the unit circle, the sine, the y value is 0 divided by the cosine value of 1. 0 divided by 1 is 0, right? So at 0, tangent 0. At pi over 2, the sine value, the y is 1, but the cosine is 0, the x value is 0. So sine divided by cosine, 1 divided by 0 is undefined. Okay, so pi over 2, it's undefined. And then similarly, negative pi over 2, sine, the y value is -1, but x, the cosine, is 0. So -1 divided by 0 is 0. So at 3 pi over 2, which is the same thing as negative pi over 2, tangent is undefined. Okay, so then I can see that the asymptotes for the parent function occur every pi units. Okay, but we normally have a period of pi. In this case, it's 2 pi. And, well, let's just start with 0. Okay, so again, at 0, so tangent of 0 degrees, or 0 radians, is equal to sine of 0 over cosine of 0, which is, again, sine is the y value, cosine is the x value. Okay, so tangent of 0 is 0. So we have a phase shift of -2 pi. So instead of the x value being 0, the x value will be -2 pi. Okay, and there is no midline shift, so it's just at 0. Okay, so now what about my asymptotes? Well, I know that the asymptotes are, or the midline point is halfway between the asymptotes. So in this case, the whole period's 2 pi. So if I want to spread that out evenly around here, I need to do half on each side. So half of 2 pi is pi. So I go pi to the left and have an asymptote. And I also go pi to the right and have an asymptote. Okay, so what other points do I know for tangent? I know that halfway between the midline point and the vertical asymptote is an important point. And then in this direction as well. Okay, so I know that the amplitude affects sort of like the vertical stretch. It tells you how high up the other important point is. So in this case, the amplitude of 0.5 says I go just half a unit above the midline. So here's 1, but I only want to go half of that. And then similarly over here, I know that the general shape of a tangent function looks like this. So in this case, I'm going below the midline. So half a unit below 0 is negative 0.5. Okay, so again, you could have done this exact same graph over here as well.